Hi, I'm Shaun.
I'm John,
I'm Mike Varney.
and we did the project number 4, the IMF Commodities Database and Prediction. So Mike's going to show you what he did first for compiling the data.
I was responsible for pulling the data off of the IMF website to get it ready for the plots and such. And also I did the code for the monthly plot, the yearly plot, for the bar graph, for the quarterly bar graph, a yearly bar graph, and also to pull the data from the Wall Street Journal website to compare with the predicted prices. Here's an example of one of the graphs.
Okay, and this graph is showing what exactly?
This is the monthly for
Between
one of the indexes.
between March 1980 and March of 2012 for bananas.
Yeah, basically all what's available.
Okay. There you go. I'm gonna just do this stuff here. So I'm John. My job was to do the EMA function to find out what the estimated the exponential moving average was, and to do the predictor function. So I did 2 different functions and passed them both to Shaun, who compiled all the work. The first one was the exponential moving average. The second was the predictor function. So for the exponential moving average, you have to decide where to start your prediction from. So I decided a good place to start, if this thing's going to trend over a whole year, is to take the average from the year before the one that we're going to be predicting with. So I took, for example, from March, if you want to predict what it's going to be for the upcoming month, I took from March 2011, because it's March 2013 right now. From March 2011 to March 2012, I took that data from that vector, and I just took the average of that data. And that was going to be where I started the exponential moving average. So for example, in January, it's going to be the average from the year before, and then times K. K, I did some research on the internet, and it said a good value for K that is good for both short-term and long-term is 2 over n plus 1. But in our case, n is generally going to be 12 because we're using a year's worth of data to predict. So that's the formula. That's going to be last year's average plus K times the current price in January, minus this average here from before. This is the same value in both places. And then so to predict, I took the last year's worth of data. So that just comes out of the vector from the stuff that the other guys programmed. It's going to take from March 2012 to March 2013 and put those into a vector. That vector is the solid line here. So this will be, for example, March 2011. This would be March 2013, and it just followed. Each one of these data points is just. This is just an example. This isn't any actual data. But each one of these points is a different point, a different month. And so the exponential moving average takes that data, plugs it into this formula, and for each one of those formulas, it spits out a new vector, and those data points are plotted among this. So you can see it just kind of lags behind and follows the original data. From that, you have to make a polyfit function that basically takes the vector created by the dotted line points and makes a new vector out of them, and then the polyfit function fits all of that to a new function. I chose n equals 4 because it's responsive to the individual points, but it also maintains a strong trend. There's no graph of this line on here. So from that, I took those 12 months of data and I just extrapolated 1 extra month on top of that, the 13th month. So this predictor line is an example of the original polynomial following this trend, and then the extra month on top of data that we're going to have to guess for. So all the data from month 12 to the end of month 13 is all predicted data. It's going to be the next month worth of data. The only problem I had in doing this was the polyval function has indexes that are integers, and you can't index a certain percentage of the month. So the longest thing that took me was figuring out a way to get 1 month worth of data into the predict line function. So I figured if you take 100 points of data per month, so if you divide, so each one of these points is 0.01. So if you divide 12 by 0.01, you'll get 1200. So it was like 100 data points per month. Multiplied that by one month over 31 days, and I got 3.23 data points per day. Since the polyval function, when you go through it, it needs an integer index, I just rounded it down to 3 points per day. So on March 1st, we're going to be on 0.1100, or sorry, 0.1200. March 2nd is going to be 0.1203, and March 3rd is going to be 0.1206, etc., till the end. And then there's a native function that goes in and finds the day, and I just have it find that day, and then when you query it, it just matches that day to the day that's on the Wall Street Journal data. And that's it for the predictor function.
So what I did is I took all of the code that both John and Mike gave to me, all their functions, and then I implemented it inside the GUI. I designed both the GUI interface, and I also designed how the logic behind the GUI works. So for example, say we wanted to go to a commodity. We would choose, okay, first off we would choose either a commodity or an individual commodity.
Maybe you should start the GUI from the beginning to show how it works with the different drop downs.
You just hit play with that.
Okay.
Give us there.
The GUI pops up right here if you hit play.
No, there it is. So first off, you'll start the GUI and you choose what kind of index you want to use, either the commodity price index, which is a grouping of indexes, or use an individual commodities. So we'll start with just with the commodity price index. Now we choose which one we want to look at. For this one there's 10 different options. So we're just going to say food and beverage. Now we want to know what kind of graph. We have 4 options: per month, every year, every quarter, and every year. 2 of them are line graphs, 2 of them are bar. We'll just do per month. Up here, it will give you the data that we have valid data points for. So for food and beverage, we have data points between 91 to 2013. Then if we want to plot it, we go over here and you enter a valid month, and you hit graph, and it'll graph it. So I took care of how all this works.
Okay, and that is pretty much our whole program. Thanks a lot. Once again, this is Shaun.
Shaun.
I'm John.
Mike.
And that's Mike.